Hey guys, I'm going to do a quick video to show you how to work these problems to determine if the equation is balanced on both sides, which means that it follows the law of conservation of matter. If the atoms are not equal on the reactant side and the product side, then it does not follow the law of conservation of matter. So the first thing that I like to do when I'm working these problems is to draw a line underneath the arrow. Everything that comes before the arrow are called the reactants, and we're just going to list the elements that we have on the reactant side. Every time I have a capital letter, that tells me it's a new element. So I've got hydrogen and I have oxygen. All right, on the reactant side, I have 2 hydrogens, so I'm going to put a 2 here. And on the reactant side, I've got 2 oxygens, so I will put a 2 here. I'm going to write down the same atoms on the product side, and I have 2 hydrogens, but this time you'll notice I have 2 oxygens here, and if there's no subscript, it's understood to be 1, so I have 1 oxygen here. Since they are both on the same side of the equation, they're both on the product side, I have to add these 2 oxygens with this one, so I have a total of 3. Well, notice that the hydrogen atoms are equal, but the oxygen atoms are not. So that tells me that this choice is not the correct answer because it does not follow the law of conservation of matter, which says that atoms or matter cannot be created or destroyed. So if I started out with 2 hydrogens and 2 oxygens, I have to end up with 2 hydrogens and 2 oxygens. I can't just add another one in there somewhere. All right, we're going to go ahead and do the same thing on the next problem. Again, you're going to list each element. Remember, if there's a capital letter and a lowercase letter, that means that is one element. It's a new element every time I see a capital letter. So I've got Na, Cu, and S. And I like to write these in the same order so that when I'm comparing them, it's easier to check to see if they match or not. So again, I'm going to start on the reactant side, which is before the arrow. I have 1 sodium, 1 copper, and 1 sulfur. If there's no numbers listed there, it's understood to just be 1. Now we're going to look at the product side, which comes after the arrow. You can see we've got this little 2, that's a subscript, and that goes with the sodium. And so that tells me I have 2 sodiums. Sulfur, there's no number there, so I'm going to just assume that that is a 1. Now, copper, there's no subscript, but there's a coefficient. There's a large number in the front, and we have to multiply those. So this is understood to be 1. And so 2 times 1 gives me 2. Well, now we can see that the coppers do not match and the sodiums do not match. So this does not follow the law of conservation of matter. You are going to continue to keep working these problems until you find the one that does have the same number of atoms on both sides of the equation. You are still required to work all the problems, even if you find one that does work. And remember, it makes it a lot easier to match these up and to check them if you write them in the same order on the reactant side and the product side.